Welcome to our tutorial for question 11 of our weekly review. In question 11, there are actually quite a few concepts that are going to be covered throughout the course of the year. Those things are always going to center around algebraic expressions. If you remember, question 10 every week is a numerical expression. Those numerical expressions are written out in words. These expressions are going to be written out with numbers and math symbols, but they're also going to include algebra, and we're going to talk a little bit about what that means. These questions on question 11 are also going to talk about algebraic equations, and they're going to talk about algebraic inequalities. Let's start by defining what each of those three terms mean. These are all three really important terms for us throughout this year to become familiar with. An expression, a simple way to remember that, is that it's just a math sentence without an answer. There are some more things to it than that, but we'll leave it simply with that for right now. I'm going to give a quick example of a math expression, and a math expression might look something like 3 plus 5. Now, in your head, you might be thinking that you know the answer to that. And so even though this question does have an answer, unless we write it with an answer, it is still considered an expression. An equation, as you might be thinking, is going to be that math sentence that does include the answer. So if I were to change the example from above, from 3 plus 5, and I made that 3 plus 5 equals 8, I've now created an expression. These two words can sometimes confuse us, and a lot of times that's because we use them interchangeably, or we use them to mean the same thing, which they don't actually mean exactly the same thing. And we'll look at an example of why in just a moment. So it's really good to start thinking in your brain about what these words, expression and equations, mean. The last word that we wanted to describe here was that word inequality. And an inequality is simply quantities that are not equal to each other. And I like to define that word quantity by thinking of expressions. So I can have two different expressions that represent quantities. An example of that might look something like this. 3 plus 5 is greater than 2 plus 4. And that's an example of an inequality. Now, this question 11 is not just about expression, equations, or inequalities. It's actually about algebraic expressions, equations, and inequalities. So we also need to go back and think about what that term algebra means. For many of us, question 11 is going to be our first real introduction into algebraic thinking and algebraic expressions. The great part is even though you don't know it, you've been working with algebra for a lot of your math career already. Algebra is really, if I'm going to define and go back and think about that, algebra is really talking about where those unknown parts are in an equation. And a lot of times, prior to 6th grade, you might have represented unknown things with symbols or pictures. But in 6th grade, we're going to start to represent those things with variables. And variables are simply letters that stand for unknown parts of an expression, an equation, or an inequality. So let's go back to our three vocabulary words, and let's look at what these might look like as algebraic expressions, equations, or inequalities. So I know that a math sentence without an answer is an expression. Well, our first example of 3 plus 5 might not have made a lot of sense because we know the answer to that. But when we look at an expression and we include algebra with that, if I had a different example that said 3 plus x, That's an unknown part. Now we see why expressions are different from equations. 3 plus x is unknown. Because we don't know the value of what x is, we can never know the value of that expression itself. 3 plus x right now could represent an infinite amount of quantities in this example. Let's contrast that with another example where we have an equation instead of just an expression. So in this case, I could write 3 plus x equals 8. Now that turns into an equation. And we already know the value of x in this because these two examples are related. There's only one value in this equation that would make this equation true. 3 plus 5 is the only way to end up with 8 in this example. And so we would know in this example that x was equal to 5. Remember, in an expression, we won't know what the variable is equal to, but in an equation, we can find that out. Lastly, we could look at the same thing with an inequality, and we could say something like 3 plus x is greater than 2 plus 4. Let's go ahead and take a look at some examples of how to work with and solve some of these types of questions that will be on question 11. We're going to start with an inequality. The first several weeks of our weekly review will include inequalities. So we're going to start here. So let's start with the exact same example we had on the last page. 3 plus x is greater than 2 plus 4. The first thing that I'm going to notice is that the left expression in that inequality, I don't know enough information about that right now. But the right side of that expression, I actually know what that's equal to. So I might be able to make this problem a little simpler to look at by simply rewriting it as 3 plus x is greater than 6. One way to think about inequalities is to think about inequalities by using a number line. So here I have a number line. I don't need all of the numbers on my number line, but I'll include a few numbers that are there. Because I know that I'm looking at values that are greater than 6, what I can do in this example is I can simply draw a circle above 6. Now, I know that the left side of my expression, 3 plus x, cannot be 6 because it says that it's greater than 6. But I know that it could be just a little bit more than 6. Like it could be 6.1, or it could be 6.5, or it could be 6.79, or it could be 7, or 7.88. In fact, it could be all of those values that are that direction. So x plus 3 could be anything that sits in that place. And in fact, we have to remember that number lines also extend forever or infinitely. So in this case, x plus 3 actually could be any number that is greater than 6. And there's a lot of numbers there, so I just drew that infinity symbol to help me represent that. We could also take a look at this same example of 3 plus x and 2 plus 4, but this time I'm going to switch my inequality symbol, and I'm going to say that 3 plus x is less than 2 plus 4. In this case, I'm going to start with the same step. I'm going to simplify the right side of that expression, and now I have 3 plus x is less than 6. Well, the same process is going to be true for this example. I know that the answer cannot be 6, so I can start by drawing a circle there, and I can mark any value that is less than 6 on my number line. As a reminder, as we do this, that extends infinitely. Let's go ahead and take a look this time at an equation. So here we have 3 plus x is equal to 8. Let's talk about how we can solve an equation. Solving an equation means that we're trying to find the value of x. Many of you probably already know the value of x. We talked about it in the beginning example of this video. If I was working with numbers that I didn't know what the value of x is, I have to kind of think in reverse. In this case, I can start to undo this problem. And by undoing this problem, I mean that I can get rid of things that are with the x. I don't want to know what 3 plus x is this time. I just want to know what x is. So I'm going to get rid of that 3 by subtracting 3, and I'm going to do that on both sides of my equation. That will tell me that x is equal to 5. And hopefully that matches what we knew from the beginning of this video. We could do another quick example, this time with a different operation. Here, if I said something like 12 times x is equal to 36, I would again want to kind of work this problem in reverse. Now, you might know what the answer to x is in this problem or what x is equal to, but we can always find that by working in reverse. In this case, we can divide both sides of our equation by 12, and that would tell me that x is equal to 3. I can also always check that my equations work, and I can do that by simply replacing the x in the original expression with whatever I found x to be in this problem. And if it is equal to the same answer, then I know I got it right. In this case, 12 times x equals 36, turned into 12 times 3, and I'm going to check that that does equal 36. If it does, then I know that I'm good to go. Lastly, just talking about expressions one last time, we can remind ourselves and think about the reality that expressions don't have answers. But sometimes there are some things we can do to expressions that will help make them a little bit easier to work with. In this example, I'm going to notice that I could never do anything with 3 plus x. Just like in our first example of an algebraic expression, 3 plus x will always be unknown until we have more information, because x right now could represent any number. However, hopefully we can recognize that there are some things in this problem that we can do some math with. So for example, I can look and notice that 3 plus 7 is equal to 10. I can add those things together because they're the same thing. If I'm using that same information, I know that I can also put two x's together. I have an x and an x, and I should be able to put those things together to show that I have 2x. So in this case, I had an expression that had 4 parts to it. 3 plus x plus 7 plus x. And I was able to simplify that or write that in another way that only had 2 parts. 10 plus 2x is equal, 10 plus 2x. Both of these expressions say exactly the same thing. One just might be a little bit simpler to work with. Finally, since we learned some steps about solving algebraic equations, I thought we might do one final example about how we could use those same skills to help us solve an algebraic inequality. In this case, if I were to rewrite our equations as 3 plus x plus 7 plus x is less than 26, I know that that can simplify down to 10 plus 2x. It's also going to be less than 26. And I can apply all of my same rules to solve for x as I did with an algebraic equation when I'm working in an inequality. In this case, I could subtract 10 from both sides. That would leave me with 2x is less than 16. And then I could divide my x's by 2 so that I end up with just 1x. I'm dividing both sides by 2, and that would tell me that x in this expression is in this inequality is less than 8. Finally, I can apply my skills that we talked about before on a number line, I could show that value of 8, and I could show any number that is less than that value of 8 would be equal to x in this example. I hope that that's helped you. Like always, good luck and keep up your good work.